Hi everyone, this is going to be a short review video on some of the very basic ideas, themes and things that are going to reoccur. I uploaded the PDF already and ideally you would go through the examples, see what you can do, see what you can't do, see what you're struggling with, and then you can take a look at the videos. So this is very basic stuff. Five ideas that I've picked up for this video. So let's start with solving equations. What does it really mean to solve an equation? So here the idea is that of an inverse operation, meaning there is a duality between doing something and undoing something. Yeah, meaning that for example, if you add, the dual to adding is subtracting. The dual to multiplying is dividing. And like a dual for, so most of our ideas that we know of are duals, like up and down, left and right, north and south, and all of those ideas. So basically what an inverse operation does is if you do something and then you undo it, you've basically done nothing, right? So that's the idea behind solving equations. So for example here, I'm trying to solve for x. What that means is I'm trying to isolate for this variable x. So first of all, I'm going to get rid of everything that is not associated with x. Yeah. So first of all, there's a 2 being added here. So I undo that addition with a subtraction. And when I do that, I have to do it on both sides because it's like a scale. Whatever operation you do on one side has to be done on the other side to maintain the equality. Okay. This becomes 3x equals 5. Now you want to undo this multiplication. So to do that, we use division. So you get x equals 5/3. Now what this really means is if x has that value, then this statement is true. Okay, so what this means is if, let's call this statement A, if x is 5/3, the statement A is true. For any other value of x, the statement is false. That is the idea. I'm going to skip the second example and have you work on it on your own. Now here you have an x squared, so the first step is still the same. Now the undoing operation for squaring is square root. So in this case, you end up with x equals plus or minus 2. So here there are two values of x for which this statement is true. For every other value of x, that statement is not going to be true. The second recurrent idea is going to be trinomials. Essentially speaking, what is a trinomial is it's an expression with 3 distinct terms. Okay, so for example, x squared plus 2x plus 1, and a non-example would be x squared plus, let's say, x plus 2 plus 3. Yeah, because this can be combined into x plus 5. Now in your previous classes that you've taken, you've learned something called factoring, and the basic idea behind, or the purpose behind factoring, is to convert sums into products. Okay, now why is that important is because if let's say I tell you that there are two numbers a plus b and they add up to 0. What information does that give me about a and b? This does not tell me much because there are infinitely many ways in which this statement can be true. But if I say a times b is 0, then within the framework that we work in, we know that A is 0 or B is 0. So essentially the process of factoring lets us derive more information. One of the ways that you learned for factoring in previous classes is called splitting the middle term. So for example, procedurally what happens is if you have x squared plus 5x plus 6, I rewrite 5x as 2x plus 3x. Then I have 4 terms and I factor out what I can in the first, plus 3x plus 2. And now here x plus 2 is common again, so this is an x plus 2 times an x plus 3. So that's basically what splitting the middle term means. Now let's look at some examples. Now remember, the idea behind splitting the middle term, what is that? Is find two numbers such that their sum is negative 5 and the product is 1 times 6, which is 6. So you look at these coefficients, the product should be these and the sum should be negative 5. Now since it's easier to work with products, let's see how many ways can I get a product of 6. I can have 1 times 6, I can have 2 times 3, 3 times 2, 6 times 1. I can also have negative 1 times negative 6, negative 2 times negative 3, negative 3 times negative 2, and negative 6 times negative 1. Now for each of these, let's see what the possible sums are. That's 7, 5, 5, 7, negative 7, negative 5, negative 5, negative 7. Now what works for us, what we need is the sum to be negative 5. And that happens precisely here. Right? Which means I'm going to split these as x squared minus 2x minus 3x plus 6. So I'm going to skip the middle step here and to try that it comes out to this. Okay, now for the next problem I'm going to skip showing this part where we actually look at all possible combinations and derive the value, and I'm going to directly go over to splitting the middle term. So in this case the middle term splits as 6x minus x, 2x, x plus 3 minus 1, x plus 3, which then becomes 2x minus 1, x plus 3 equals 0, which we know in our system, when the product of two things is 0, one of them has to be 0. So this gives me x is 1/2 or x is negative 3. So these are called the solutions. Now a natural question to ask is, well, can this splitting always be done? And in some sense it can always be done, but it may not always be simple. So for example, here we are looking for two numbers whose product is 1 and whose sum is 1. Now it's already obvious that this particular condition cannot be obtained using very simple numbers, right? Because the most simple way of getting a product of 1 is using 1 and 1, but 1 plus 1 is 2, so it doesn't work. Which means that there are some trinomials which cannot be factored by our current method. For that, in previous classes you learned something called the quadratic formula, which says that if you have ax squared plus bx plus c equals 0, where a, b, c are real numbers, then the solution can be written as negative b plus minus b squared minus 4ac over 2a. Now this can be derived using completion of square. Okay. Now at this point I'm going to assign a bonus. Bonus is derive the quadratic formula using completion of square. Okay, this is something you have seen in your previous math classes, so hopefully you remember how to do that. Again, because completion of square is a pretty handy tool in mathematics. Okay, let's look at the example here. Solve for x. So here, if you notice, a is 1, b is -1, c is -1, right? So our equation is going to be -b plus minus 1 squared is 1 minus 4 times 1 times -1 over 2 times 1. So it's 1 plus minus 1 plus 4 is 5 over 2. Okay, I'm going to leave this one for you to do. Then there's also something called quadratic-like equation, meaning that it can be made to look like a quadratic via some substitution. Okay, so it's more like you're going to have to look for a pattern. For example, here I have an x to the power 4 and then I have an x squared. So if I substitute u equals x squared, this becomes u squared minus 4u plus 3 equals 0, which is now a quadratic in u. Okay, and this the middle term splits as 3u u. What does that give me? U times u minus 3 minus 1, u minus 3 is 0, u minus 1, u minus 3 is 0, u is 1 and u is 3. But remember, you're not done, because what is u? U is actually x squared. So you have x squared is 1 and x squared is 3, which then gives you x is plus minus 1 and x is plus minus square root of 3. Remember, the undo operation for squaring is square root. Now similarly here for this problem, you substitute 1 over x and this becomes u squared plus u minus x equals 0, and I encourage you to finish this. Okay, I'm going to end this video here because I don't want my videos to be too long. And then we have 3 more ideas to talk about, which we're going to do in the next video.